Hello, we're going to be doing solving compound inequalities today. So our learning target is just that. I can solve compound inequalities with one variable. A compound inequality is when we have two inequalities that are being applied at the same time, and we apply them in one of two different ways. So I'll skip down to the bottom here for a second. One time we apply it with the word and. When we say one inequality and another one, we mean when they both are being applied at the same time. So if I have two inequalities that look like this, I only care about when this one and this one are being applied. And what that looks like is I only keep where they overlap. So I would only keep this spot. And my final inequality would look kind of like Baymax's eyes from Big Hero 6, where it's two dots on one end and a line in the middle. So when it's an and, we only keep the overlap. So where one and the other one are being applied. So I'm going to put only. An or statement, so this one or this one could be there or the other one could be there. It doesn't matter. We keep it all. I'm going to say keep everything. Okay, so what this would look like is if I have them separated, meaning they're not overlapping, but this one's being applied or this one. They don't both have to be applying at the same time, meaning they don't have to overlap. I'm going to keep it all. Okay, so your ORs for this lesson will only ever look like that, where they have a gap in the middle. But let's practice graphing. So let's come back up to the top. If I'm saying x is greater than 7, then I'm going to find 7. And I'm saying greater than, not greater than or equal to. So I can't include 7, meaning I'm going to have an open circle. I'm going to leave 7 open because it's not being included. But I'm saying everything bigger than 7. X is greater than 7. Well, numbers bigger than 7 are 8, 9, 10, 11, 12. Okay, so that's kind of how we think about graphing. Like, think about what I just said. That is our thought process when we're graphing. Okay, let's do it one more time. X is less than -4. So that's an open circle on -4, because that's the number they gave me. And it's saying just less than, not equal to. If it's equal to, then I include the -4, meaning I make a closed point. But it's not. So we're going to do x is less than -4. Numbers less than -4 would be -5, -6, everything off to the left over here. Okay. And if I'm doing a compound inequality, that just means I'm applying both of them on the same graph. Okay. So if this was an and, they don't overlap. So we wouldn't keep anything. If this is an or, we keep it all. Doesn't matter if it's overlapping or not. Okay? So the words and and or, they make a difference. So let's see in what Delta Math makes us do. Okay? So I need to solve both inequalities before I can start. So we're going to do that really fast. I'm going to do it here, but then I'm not going to do it for the other examples to save us some time. Okay? So we're going to subtract 6 on both sides, and that makes -15 is less than or equal to -3x. I divide by -3 on both sides, and because I'm dividing by a negative, I'm going to get 5. Instead of less than or equal to, I'm going to flip it. It's going to be greater than or equal to x. I'm going to do it again over here. 24. Divide by -3. And I get x is, instead of less than or equal to, it's greater than or equal to 8. Now I wrote them at the top because this might not be what we end up writing down here. Okay? what we write in here has to match up with what we graph here. So it's easier to see it first. So I'm always going to tell you, same with your steps, graph before you write anything in that little box there. Okay, sometimes you don't have to change anything up, but sometimes you do, and it's better to not waste your time, right? So let's graph. I have 5 is greater than or equal to x. So I'm going to start on 5, and that's going to be a closed circle because it's equal to. And I'm saying 5 is greater than x. 5 is greater than 4 and 3 and 2 and 1. So those are numbers that I need to have under my line. So this is going to go off to the left. X is greater than or equal to 8, so I'm going to put a closed circle on 8, and I'm looking at numbers bigger than 8, so that's going to go off to the right. Okay, this is an or statement because it told me. You don't have to go figuring it out. You don't get to decide. It'll tell you. It's an or statement, meaning I'm going to keep it all, no matter if it's overlapping or not. So I'm keeping this piece and this piece. And if I have 2 pieces, I have to write my inequality notation box as 2 pieces. And it ends up being kind of simple because it's just what we had. But I'm going to put an or in the middle. That's going to split up my one piece with my other one. Wrong sign. There we go. Just like that. Okay. Please note, this means the same thing. If you decided I wanted to put x first, you can do that. So, for example, our inequality got us 5 is greater than or equal to x. If I want to flip the x and the 5, I can absolutely do that. But I also have to flip the sign in the process. So it has to also flip. So this is the same as this, as long as everything is flipped, okay? And you are more than welcome to do that. Delta Math will not mark you wrong if you want to flip your inequalities, okay? Let's look at an and. Remember, and is when we keep the overlap only. Keep overlap. So I am going to just tell you, because we're not going to solve all of these. We know how to solve inequalities. That was done in 7.1. So if you need help with that, please look at the 7.1 video. Let's see. This is what we get when we solve for x. So let's graph. -3 is less than or equal to x. So I'm going to go close circle on -3. -3 is less. So everything else needs to be bigger. So I'm going to go this way, and then 3 is greater than x. So 3 is bigger than everything else, so I'm going to go this way. Okay, this is an and statement, which means I'm only going to keep where they overlap. And they only overlap from -3 to 3. So here's what happens. I'm going to actually erase it. You're going to keep it on your paper. But just so you guys can really see what Delta Math will look like, you would click and then drag and drop it right there from -3 to 3. 2 closed circles, because that's what we have. 2 closed circles. Okay? Looks like Baymax's face. Right? So, if I wrote my inequality in one piece, right? Click, drag, and drop once. Click, drag, and drop once. Then I have to write my inequality in one piece. Okay? And here is how we do that. We're going to put x in the middle. Everything is going to be the x is going to be sandwiched together with the other inequalities. And I'm going to put -3 on this side. And when -3 is first, it's a less than or equal to. Less than or equal to. This one I need to flip like I did earlier. So we're going to go x and 3, and if I'm flipping the number in the sign, or if I'm flipping the number in the letter, then I need to flip my sign. And it's going to look like that. So what's happening is I have -3 is less than or equal to x, and combined, x is less than or equal to 3. I just made the x's the same x. So I squished it together, which is what you have to do with an and, because you only have one piece. If you have one piece down here, you need to only have one piece up here. Okay, let's practice again. Ready yet? Let's see an and in a different light. Okay, we're gonna go through this one because it looks a little scary. It's new. We like to draw a line down the equal sign, or the sign. But notice we have 2. So I'm going to draw 2. Okay? My goal is the same. Get x by itself. So here in the middle, my goal is to get x by itself. And if I did not have this over here, you would probably very easily say, well, I would add 3 to both sides. I'm telling you, we're going to still do that. I'm going to add 3 to both sides. But I don't just have one side. I have 2. So I'm going to add 3 to all sides of my railroad tracks, if you will, or my lines. Okay, and then I simplify. And again, if this wasn't here, you would be like, I'm going to divide 3 on both sides. And I would say, absolutely. Let's do it. But let's do it to all the sides. And I'm going to write it up here. I would get 6 is greater than or equal to x, which is greater than -3. Okay, already squished together. I know that this is an and because it's already squished together. Did you notice how when we had an and, we squished it together? With an or, we didn't. Okay. Ors you can't. Ands you pretty much always have to because you get this one piece. So I know that this is an and I know that it wants me to graph from 6 to -3. So I'm going to go -6, or +6, excuse me, the 6. And I know that it's going to be a closed circle. And then I'm going to go to -3. And I know that's going to be an open circle because of that symbol. And I'm going to put a line through the middle like that. Just like that. What this is saying is 6 to -3. Okay? So that's what it is. It's one piece, 6 to -3. And so if I write it like that down here, I have to write it like that up here. And because it was already squished together, I am done. I don't have any more work. That's my answer. What I got is my answer. Okay, let's practice an and one more time, and then I'm done. Solving for x, this is, let's see, 5 is less than or equal to x, and x is less than 9. So let's practice graphing. Remember, it's an and, so I'm keeping the overlap. I'm throwing away everything else. Let's see, starting on 5, closed circle, and that line is going to go, we're saying 5 is less than x, so everything else has to be bigger. So it's going to go that way. And I'm saying x is less than 9, so open circle on 9, and everything is less. So it's going to go this way. This is an and, so everything that is not overlapping is going to get thrown away. Everything that is overlapping got highlighted, and that's all I'm keeping. So closed circle to open circle, Baymax's eyes. If I find my final is in one piece, then I have to write my inequality in one piece. And this is kind of nice. It's making it easy for me. I'm going to write it like this. It wants me to squish it together. So these x's are just going to become the same x. And I'm going to write it like that. Here's a trick. If you've written an and right, then the signs will always be going the same way. Okay? They can be going they can both be going this way or both be going that way, but the signs will always be pointing the right way. They'll always be opening up the same way. if you've written an and statement correctly. Okay, so that's all I have for you today. Thank you for listening. Email me if you have any questions. Thank you.